before we do our task, let's review our norms, and then you are all going to vote on a norm to choose for today. Okay? So, I'll go ahead and read these. Number 1, everyone can learn math to the highest levels. So you're going to think about which one do you want to focus on. Number 2, mistakes are valuable. Number 3, questions are really important. Number 4, math is about creativity and making sense. Number 5, math is about connections and communication. We did a lot of that with the challenge course, communication. 6, depth is more important than speed. So it's better to understand it than to be the first one done. And number 7, math class is about learning and not performing. Okay, so now you're going to raise your hand if you want to focus on one of these. Okay, raise your hand if you want to focus on everyone can learn math at high levels. Okay, 2. Mistakes are valuable. You just get one vote. Do you want me to restart?
Yeah.
Okay. Number 1, vote for number 1. Okay, number 2, mistakes are valuable. Number 3, questions are really important. 2 votes. Number 4, math is about creativity and making sense. 1 vote, 2 votes, 3 votes. Okay. 5, math is about connections and communication. 6, depth is more important than speed. Okay. And then 7, math is about learning, not performing. Okay. Raise your hand if you didn't vote. Suliana, which one do you want? Looks like this one's the winner. Is that okay with you? Okay. All right, Zia, we good with this? Okay, depth is more important than speed. We're going to focus in on that norm today. So when I walk around and listen to you talking, I'm going to listen for that norm. Okay, I'm going to listen to things that you're saying to help us go deeper instead of faster. Okay, so the goal is not to be the first one done. The goal is for everybody to understand deeply. Does that make sense?
Yes, ma'am.
Okay, I'm going to highlight that. Okay. What are some things we could say to help encourage that norm? What is some things that you could say to your partners?
You got this.
Justine?
Take as long as you want.
Ah, I like that. Hey, take your time. Yeah. Ivan?
Don't blame or don't say, oh, you got this wrong. Yeah, you didn't do.
Good. Yes. No put downs, because if somebody's taking longer, we don't want to put down. We want to encourage. I like that. Yeah.
Or don't quit.
Don't quit. Persevere.
Always ask a lot of questions.
Ask questions. Good. That asking questions will help you with that depth of understanding. So it's not like a partial understanding, it's a deep understanding. Good? Okay. Is it okay if this task is challenging?
Yeah.
Yeah? It's probably better. Helps us learn. Learning happens in the face of challenge. Cool, are you guys ready? Are you excited? Woo! All right, hey, who wants to win the Growth Mindset Award? We gotta hear some excitement. Are you guys ready?
Yeah.
Woo! I can do this.
I want to win again.
All right.
We could, right? Win again. Yeah. It's no
All right. Everyone write your name, first and last one on the top. And may I have a volunteer who would like to read? Suliana.
A child was stacking marbles in an interesting pattern. You were noticing this and thought that maybe you could use your excellent algebra skills to predict the total number of marbles for any p number of piles of marbles. There are four piles shown below. Use any piles you can see to fill out the table and write your expression.
Okay, thank you, Suliana. Everybody, please reread this for understanding and making sense. Underline the important parts. Everyone, reread it. Go. underline the important information. Can somebody explain me this task in your own words? What's happening? Adara?
It's adding to model each time.
So I think you're already looking for patterns. I just want to know like what's going on. Like what are you seeing? Who's stacking the marbles?
Kid. The child.
A child, a kid. Okay. And what is your task? What is your objective? Yeah. You want to know an expression for P. And what does P stand for?
Piles. Was.
Piles.
Oh.
Piles. So this is a pile. This is the first pile, 1. This is the second pile. Third pile, fourth pile, fifth pile, 6, 7, 8, 9, 10. Have a seat, Joe. You have a pencil here. Let's eraser. 30, and then P piles for any number P piles. Does that make sense? That's what I mean by pile. Okay? So your task is to fill out the table. After you fill out the table, you're going to look for patterns and then use those patterns to write an expression. What goes here? Raise your hand. Brixa?
Model. Like draw. Model and explain it.
You can explain your expression, how it connects with your model. Good. What else goes here? Anybody else? Suliana?
You're explaining.
Yeah, your justification. Good. Okay, don't fill out your table yet. We're going to start with some tiles. So I'm going to have the yellow start, and you're going to make the first 2 models. So yellow person, because the first model is pretty straightforward, as you can tell. All right, yellow. Yellow, go ahead and take out a tile and make the first pile. All right, how many are in that pile, class? 1. Fill out your table.
Oh.
Fill out your table. There's 1. 1 pile, 1 tile. Okay, same person, yellow again. Yellow again. Make the second pile.
Oh.
Yellow, make the second pile. How many are in the second pile? 1, 2, 3? 3. Fill out your table and pass your manipulatives to the right.
Oh, I see.
And this person now make the third pile. Make it look like the picture.
Oh.
Does that look like the picture?
That look like the picture? Yours does. Yours, yeah, like yours is like actual piles. Yeah. Third pile.
6. That's 5.
That's okay, you got this.
I'll do 5.
How many do you see, class?
5.
5. Okay, does everybody understand? Okay, eyes up here before I launch you. So you're going to pass the tiles to the next person, and then you're going to work together. And I'm going to listen, remember, for depth of knowledge in working together. Any questions? One more thing. Be prepared to present your findings. Be prepared to explain your expression and where it came from. Okay? All right, get to work. Go.
All right. You make the next pile. Make the next. So that's 7.
Wait, you guys don't use
No. You don't need it.
Yeah, because you have to add.
Yeah, we're gonna have to add it for the next one.
It goes by 2.
Yeah.
So like 2
So-
plus 1 is 3.
3 plus 2 is 5, and then 5 plus 2 is 7. So the next one's gonna be 9.
Wait.
Do you really actually know it's 9?
Yeah, because we see a pattern right here. Because 1 starts out as 1, and then it goes to 30 by 2s, and then so it's just counting up by 2.
Can you represent that on your paper?
Yeah.
That pattern that you see?
Yeah.
Oh.
So like that.
Mm-hmm. You see that, Rixa? Like that? That's nice.
2 plus 2. It's just gonna count up and then
Oh, I said
plus
times 2.
that's 11 and then plus 2.
And then we could do since like pretend this is a 6. 6. I don't know.
The P I think is gonna be like
We can multiply by 5.
no. See, she said show how.
What is 10? Oh yeah, it's going to be trash. It could be possible. 1, 2, 3, 4, 5, 10.
I mean, same thing for
Yeah, it is. You're adding 2.
Where did this come from?
You see, it's going like 2.
What about 30
Times 5? Because you're times 5. So, okay, good. So anytime we have an expression, what should we do? Write it down.
The total in the next circle.
So it's P times 5. And then after we write it down, we should always check it with the table. Now let's check it. Okay. So let's start with 1. What is 1 times 5? 5. Did that work?
Yeah.
That's okay. That's totally fine because now we know that it's not P times 5. And then we can go in a different direction. 1 times 5. Was that too big? Too small?
No, it's 6 plus 2.
Do you notice any patterns with your table? Like any additive or
Multiple 2.
added by 2?
Yeah, 2.
Can you represent that on your table?
But then 1 times 2 is
5 times each.
Well, that didn't work, right? Because 5 times 2 is 10. That's too big. But can you show your additive pattern on your table?
Yeah.
Represent that. So I can see the patterns that you're picking up on, like this, like plus 2.
So,
Plus 2.
you could write a 5. You could do a 10.
Let's do it instead.
Like that?
Yeah,
We can start. We can start.
What do we call that?
So it's times by 2 at a time.
Repeated addition? What do we know about repeated addition? Do you remember what we call that number? Who has pet? You have first grade, you have second? Do you remember what we call that number?
It shows 3, right?
Is this the starting value? Plus 2, plus 2, plus 2, is that where it starts?
Yeah. No. Yeah.
Yeah?
No, but isn't it like
Look at is it the starting value or the other one?
Oh, it's the starting.
Are we, it's okay, we're confused. So let's go back to our models. Okay, go ahead and make your first model. Yeah, you're gonna make your first model? Yep, perfect. And then make the second one. Now make the third pile.
my hands are clasped.
Okay, and I'll use these to make the fourth.
So 1 is 9, so it goes up to 2, right? So 1 more. is 10.
If you add going up by 2.
Oh,
is 13.
Okay, so this is the first pile, 1. This is the second pile. This is the third pile. This is the fourth pile, right? So the starting point is the 0 pile. And then you told me that the starting point was 2. So are you telling me that there's 2 at the starting point? Does that follow the pattern? No. So 2 is not the start. Okay, what is 2? The rate. The rate. Yeah, it is the rate. That represents the rate. Can you guys mark that on your paper?
So the 2 is the rate.
The 2 is the rate. And then you said something about repeated addition, which I liked. What do we know about repeated addition? Repeated addition is the same as multiplication. Yeah, let's try that. Let's try that. So it's not p times 5. We already figured that out. So what else could we try?
Now we just, this one we
The rate,
yeah.
which is 2. So let's try that. Write that expression down. 2 times 2. Okay, now anytime we have an expression, we need to test it. Let's test it. Okay, what is 1 times 2? 2. Oh, it doesn't. Let's keep going though. What's 2 times 2? 4. Oh, that's not working. What's 3 times 2? 6. Oh, it's not working. What's 4 times 2? 8. It's not working. But are we close?
Yeah, we're
Maybe use that information to help define the pattern. Are you guys more confused or maybe just a little bit of it?
1. What about 1?
Thank you.
Aha! I don't know. What about 1?
Yeah,
Work
so
together to figure that out.
times 1 is
Yes.
1 times 1 would then. Wait, no, that would
2 times 1 would be
30. Okay. So
Okay, so we know it's 2 times something, and p times 2, 1 would be off. But then,
number of circles is 99, and we just add 2 times 1.
Oh, I like that. So you added 2 plus 1
p times
plus
1
1
is
plus
then
2 plus 1 plus 5.
that would,
So you're like plus 2 plus 2 plus 2 plus 2 plus 2.
p times 1 would be the same number that
So let's
we started with, so none of the numbers would change.
Okay, what's 2 times 2?
What about 3?
So it look like that.
1 times 3.
Where's that? Like that. 2 times 2 is 4. And then you take away 1.
Dang it.
So it's 3. Okay, let's look at this one. What's 3 times 2? Okay, but then take away that 1.
Now it'd be 6.
What's 6?
No, 5.
5. Okay, show me how that happens with that.
So there is 7 times, 4 times 3, right?
4 times 3 is
4 times 3 is 12.
Do you want to draw that invisible one?
Yeah. So we add it right there, right?
So how many marbles is that?
That's 8.
8.
Take away.
Take away 1,
7.
and then that's going to be 7.
7. So the question is, what if there were, Rick said, what if there were 30 on the bottom?
Oh, 30, 29.
So how many would be on the top? If there was 30 here, how many would be here?
4.
Here, like there's 2 here.
6.
So let's look at here. 1, 2, 3, 4. How many are on the top? 1, 2, 3.
Yeah, 4.
4.
Oh,
Isn't there gonna be reality?
so there's 30 on the bottom and 4 on the top.
If there's like 30 circles, how many circles would be on the top of all of those? Would there be 1 on top of all of them?
Yeah.
29. So all of them would have a circle on top of it except for 1.
Yeah.
Does that make sense? So what are you saying, you all? Taking that away.
Because in each here, there's 2 and then 1. And here's 3 and 2 and then here's 4 and 3.
So then if there was 30, there'd be 30 and 29.
Oh, minus the 1. Minus the 1. Oh.
Minus the 1.
Yeah,
So how many would be here?
So that's going to be 29. No, 30. No.
So you're saying if there's 30 on the bottom,
And then 29 on the top, and then minus the 1. So it's been already one, so
it's already been minused.
Yeah.
So what's 30 plus 29?
29 is 59.
Because it's a higher number.
Okay, now you gotta figure out for P. If there's P on the bottom, how would you figure out the total?
P plus
P plus 2.
So try it, and then test it with your table to see if it works.
Yeah.
Oh, test it on the table.
Yeah. P plus 2, okay. P plus 2. Yeah. P plus 2. Yeah, it's adding it, and then but the 5, it's not. Yeah, the 5, and then the 10 is the 10, yeah. It's not adding, it's adding 2, but it's multiplying,
Oh, so you can like
so people say not right. So we're gonna try a different one. Because people slow down. How about we do,
Well,
P plus 2 plus 5?
no. P plus 4. Wait, no, that would be P plus 4
I can do
plus
this.
3 plus 4 plus
I can do this, alright.
is on 1.
So starting point is when x is 0. So this would be your starting point.
Oh, yeah,
When x is 0. So if you do this pattern, what is this plus 2? So you would have to minus 2 to find your starting point. Which is weird because it gets negative, right? I think that's what's making this challenging. Okay, so now you have your expression. Is your expression correct?
Yeah.
How do you know?
Because when I do 1 times 2 minus 1, I would get 1.
I can do this.
And then when I do 2 times 2 minus 1, I would get 3. And so on.
So you cross-checked it with your tables.
Yeah.
And it works for every...
It works for everyone. Like if you did 5 times 2, that would be 10. P minus 1, that would be 9.
Okay, great.
It's 9.
So
Now we need to connect your expression with your model. Okay, so let's go ahead and look at your piles on your paper. Okay, so this is 1, and so let's go ahead and label that circle 1. Put a 1 in that circle. Okay, and then now let's use your expression. 1 times 2 is 2. So let's draw like an invisible 2 above yours. Okay, so 1 times 2 is 2, and then take away 1 is 1. Okay, it works. Now let's label this 1 and 2. With the bottom ones.
What that one?
Okay. So we take this with your expression. We take this 2 and double it. So 2 times 2 is 4. So let's add that little invisible 4. And then minus 1 is 3. Okay. Is this making sense? So now label these ones. 1, 2, 3. So if we take the bottom, double it, we get
6.
6. 3 times 2 is 6, and then take away that 1 we have 5. Okay, now do it to your last one. So how do you do the last one? How many are on the bottom? 4. And take away 1, you get 7. So do you see how your expression fits into your model?
Yeah.
It's almost like all of these circles have 1 on top of it, like another circle on top of it, except for one of them.
Because you're like, no, when you're
Does that make sense?
Yeah.
Then why isn't there a circle here?
Because you first subtract them, and then it gives you the answer.
Almost looks like that would even fall off too.
Yeah.
Like if you put a marble there, it'd be like,
Yeah.
yeah. Okay. What I want you to do now is explain it in words, connect it with your model, and then be prepared to present. Are you comfortable with that?
Yeah.
Presenting? Okay, figure out maybe who's going to share what. Maybe somebody share the rate, somebody share the expression, somebody share the model. Cool? Okay.
So we would,
Yeah, you guys got it?
we could write down the expression.
Yeah, so
We could say we got P times 2 minus 1.
we'll do 2p because it's kind of the same as 2 times p. We got 2p. Okay, we found it out. We did p times 2 because when you go to 10, p times 2 is 20 minus 1.
Okay.
And then p times 30 is 60 minus 1, 59.
Okay, so you tested it with all of them and especially these big numbers.
Yeah.
So what's your expression?
P times 2 minus 1.
Yeah, minus 1.
Aha!
Because you have to have one to get the other.
Good. And so are you convinced that that expression is correct?
Yeah.
Because you tested with your whole table?
Yeah.
Let's test the first couple also.
Okay.
Let's test this one. So Rick said, what's 1 times 2?
1 times 2 is 3.
Try again.
Oh, 1 times 2 is... Oh, times 2.
Minus 1?
1.
Good. 2 times 2?
2 times 2.
Minus 1? 3. Good, let's try this one. 3 times 2? 6 minus 1? Good. 4 times 2?
8
Minus 1?
7.
And you already told me the other 2. Good. So go ahead and fix this. You need to add the minus 2 here and then fix all these ones. I really liked how you tried the p plus 2. Is that where you started?
Yeah.
And then what happened?
And then we just told ourselves we can do it. But then Mr. Wagner told us to go ahead, and he told us to multiply it, and then we got it from there, and then we all shouted out. And then he told us it, and then we multiplied it, and it worked.
So you started with your rate and you were like adding it, and then you got a hint to maybe try multiplying it.
Yeah.
And then it worked, except for you needed to figure out the
minus
1. Which is funny because I don't think you had the minus 1 when I walked over, but you said it as you were explaining it to me. That was really cool. Okay, so now you need to be prepared to justify your answer and present. Are you comfortable presenting?
Yeah.
A challenge would be, how do you see your expression in your model? Where do you see the doubling and the taking away the 1? It'll give you a hint. What if you do the...
Yeah, that's what I
Do you see the 1? Do you see the doubling and then the subtracting? That might help. Cool? All right. How are we doing?
So-
You guys found it? Yeah. Found it? Everyone found it?
Yeah.
Okay, I think we're ready to present. Can we go first? Hey, guys and gals, do you need time to justify?
Yeah.
Okay, so let's take 3 minutes to do your written justifications. Okay, I'll be right here. Yeah. You guys are ready? Who's doing what?
I'll do this.
So you're gonna do the model. You're gonna do the table.
Wait, no, I can read the justification.
I'll do the model.
The model. Who's gonna talk where the expression came from? Kind of like the initial aha. Yeah.
You have it. You want to do it? Like how 1 times 2 and then that works over 2 lines.
Yeah, exactly.
Mr. Sharon,
Do
please
that?
call the main
Okay.
office.
All right. And you already have your written justification. Okay, so just hang tough for 2 minutes.
Did you want to do that?
No.
Wait, what do you want to do?
What's the reason?
What do I have to say?
Okay.
Do you think the expression is we double and then minus 1?
Okay, good. So let's check it with this one. So what's 1 doubled?
That'll be 2.
Minus 1?
That'll be 1.
Good. 2 doubled?
That'll be 4.
4. Minus 1?
3.
3. 3 doubled?
6.
Minus 1.
5.
It's working. 4 doubled?
8.
Minus 1.
7.
5 times 2?
10.
Minus 1.
9.
10 times 2? minus 1, 19, 30 double, 60 minus 1.
It's 9.
Should we change that?
So we're doubling it.
Okay, let's look at our model. Do you see the doubling in your model? Like, do you see this is one pile and there's one marble?
Yeah.
Do you see this is 2 piles and there are 2 marbles? Do you see this is 3 piles and there are 3 marbles? Where do you see the doubling?
Oh, when there's 3, they're doubling by 2.
So there's like 2 on the top, but then you take away 1. Okay, so where do you see the doubling here? So there's 3 on the bottom,
And they're doubling it by 2 on the top.
3 on the top, right? Doubling it, and then you take away. You don't talk to me about this one.
It's the same as this, but you're doubling it by 2 and then taking it by 1. Like that.
So if there's 4 on the top, or 4 on the bottom,
And there's 4 on the top and then take away 1.
good. Does that make sense?
Mm-hmm.
Yeah? Good. Okay, so write your expressions and then justify that here, and you can describe the model. Like if there's 4 on the bottom, and there's 4 on the top, and then you take away 1. Okay?
Okay.
All right.
What is P? P is P times 2 minus 1.
Oh, and 2p
So,
yeah.
High five.
2p plus 4 minus 3.
Okay. Bam. You're Irish. Okay. Now, do you guys want to write a model for?
And then your expression goes there.
Do you guys want to write words?
And then if you want to write it again down here, write 2p minus 1. 2p minus 1. Because remember, the coefficient always goes first. And we don't use the times, we can use a dot or nothing else. So 2p minus 1. Okay, I think we have a group who is ready to present. We're going to start with Justine's and then you will.
Let's do my paper. Are we gonna put it up here?
Yeah. So put your paper up there, Justine, and we'll stand in the front of the class. And then Addie, Justine, and Derek come up to the front.
Oh.
Okay.
So when we filled out the table, we kind of had trouble, but we went all the way until 10 because we still had to figure out what to do to get that number and that number. So what we did was since it was 10, we just added we did it on our fingers like 9, 10, 11, 12. Then we did it up to 19. And then from 19, we did that to 59. And then we figured out this because at first I was like, it's P plus 2 on this wing here. It's not that.
Raise your hand. Who else thought maybe p plus 2? Yeah. Is that okay that we thought that? Yeah, because we can learn from our mistakes. Got it. Yeah.
And then Addie came up with 2p minus 1 because it works with all of them. So like, for example, 1 times 2 minus 1 is 1. And then 2 times 2 is 4 minus 1 is 3. And so it just works with every one. And then Miss Lynn told us to make another one. So I said 2p plus 2 minus 1 and 2p plus 3 minus 2.
So those are all equivalent. Nice.
Okay. For the model, we did kind of like the same as the expression. We did 1 plus 1 and that would make us 2, but then we had to take away 1, so that would get us back to 1. And for number 2 model, we did 2 plus
Double.
Oh yeah, 2 doubled, and that would get us 4, but then we had a minus 1, so that got us to 3, and it does the same for the rest.
And we wrote for the justification, we got 2p minus 1 because, for example, 1 times 2 equals 2 minus 1 equals 1. And that works for the whole table.
Good. All right. I really like how you cross-checked with your table. Raise your hand if you cross-checked your work with your table. Did you guys do that too? Cross-check your expression. That's really good. And then also, I think in your justification, you can add kind of more what Addie said about the model. Add that to your justification. So you can see our expression in our model because when you double the bottom, you get the top and then take away that 1. Okay, good. All right, let's give them a round of applause. Okay, next group. Abina Sears group. I took this double it. Double the bottom. 3 plus 3 is 6.
And then is that better?
Oh, yes.
All right, talk to us about your process.
What we did is we thought it was p plus 2 at first, but then we got a little tip from Mr. Wagner, and he told us to multiply. So what we did is 2 times 1, that's 2 minus 1, that's 1, and then we did 2 times 3. 2 times 2 is 4 minus 1 is 3, and then we did 3 times 3 is 6 minus 1 is 5, and then we just went on, and we didn't really know it was p plus, we thought it was p plus 2, but then we found out it was p plus, p times 2 minus 1, and we, for 30 and 10, we, 10 times, we did 10 times 10, that's 20, and then minus 1, that's 19. And then we did 30 times 30, that's 60, and then minus 1 is 59.
Your operations kind of look like plus signs,
Yeah.
so I would edit that when you. That's fine though. Just edit that before you turn it in.
All right.
Yeah.
All right, go ahead.
Oh, and then for this, we found out that it was going by 2, so 2 plus 1 is 3, and then 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9.
What do we call that? Does anyone remember that? What do we call that number? The plus 2 plus 2 plus 2. What is that called? Is that the starting point? No, that is the rate. That is the rate. So UL just told you about the rate. Everyone write that down on your paper. This plus 2 plus 2 plus 2, Addie, this is called the rate. Write that on your paper. That is called the rate. That's the rate.
For this, it's the same. You know, you just.
For this model, it's the same as Opti just explained over there.
Can you describe it?
So you're adding 1 to it and taking it away.
What she's basically saying is like 2. It's the same as the model. 2 times 2 is 2 times 1 is 2, and then minus 1, and then 2 times 2 is 4, and then minus 1. And for the justification, it's the same as everything. We actually know it was 2 times p times 2, so we just multiplied it, and yeah.
Good. Okay, I have like 3 things to say. So first of all, you guys are amazing. You did such a good job. Second of all, this is what I heard. It goes by 2. Wait, do you really know it's 9? Wait, what did you do? Wait, is that right? Do you guys think you focused on depth and not speed? Yeah, you were telling your classmates to wait, and I love that. And the growth mindset winner of this week, who will get rewarded next Monday. And there was a tie, but I'm going to pick it to one person, and I'll let you know who the runner-up with. But the winner is Adi Nasir. Yay! You did such a good job. It was amazing to watch them work together. So, hey, what kind of attitude is that? Say congratulations.
Yeah.